Welcome. Let's take a look at this situation. If f of 9 is equal to 8 and f prime of x is continuous on the interval from 4 to 9 and the definite integral from 4 to 9 of f prime of x dx is equal to 35, what is the value of f of 4? Well, the fundamental theorem of calculus can help us with this problem. Notice that if our function f of x is continuous on a closed interval, which we see here it is, f prime of x is continuous on a closed interval, and note that this f of x is the integrand of the function, so our integrand is f prime of x, so we would want f prime of x to be continuous on the interval. If that's the case, then the integral from a to b of our integrand would be f at the upper endpoint minus f at the lower endpoint. Okay, so let's see how this plays out. So we know that our function, our integrand, satisfies the conditions for the fundamental theorem of calculus. So with that said then, the integral from 4 to 9 of f prime of x dx we know is equal to 35. Well, if my integrand is f prime of x, so if the integrand is f prime of x, what is the antiderivative? Well, if my integrand is f prime of x, then my antiderivative is going to be f of x. Because the question we think about is the derivative of what function equals f prime of x. Well, that function would have to be f of x. So that means that our antiderivative is f of x. So that means that I can replace this definite integral with f of 9 minus f of 4 equals 35. Now with that said, then we also know that f of 9 is equal to 8. So I can rewrite this as 8 minus f of 4 equals 35. And then solve. What am I solving for? I want to know what the value of f of 4 is. So I solve for f of 4. I can subtract 8 from both sides of the equation. And when I subtract 8 from 35, I end up with 27. Notice that I have negative f of 4, so I can multiply both sides of this equation by negative 1. And if I multiply both sides of this equation by negative 1, I get f of 4 is equal to 27 times negative 1, or more simply, f of 4 is equal to 27. I hope you find this helpful.